So the second part of the lesson is converting vertex form to standard form. Okay? Remember that the vertex form looks like this. Right? This is my vertex form, correct? Now, my standard form is going to look right? So I want to go from vertex to standard. Right? And in order to go from vertex form to standard form, I have to do what we call expand. Expand and simplify. So what we did earlier with the FOIL method is an example of expanding and simplifying. Okay? So I went from the factored form to an expanded form. We call it the standard form. Okay? So from here to here we expand and simplify. From here to here we expand and simplify. Okay? So let's look at these two graphs first. What can you tell me about the vertex of this graph? What is it?
It's 2 and 6. It's 2 and plus 1.
2 and 1. Right? The vertex is 2, 1. Right? That's your vertex? Right? Can you tell me what's your y-intercept?
5.
5 is 5. How do I write it as a point?
Y equals 5.
Okay, y equals 5. Or as a point, how do I write it?
0, 5. Yeah.
Do I have any x-intercepts or do I have any zeros?
Oh.
No. Which way does it open?
Up.
Up.
Up. Let's look at my step pattern. So if I go, I'm going up 1 over 1, right? And I go up 3 over 1, right? My step pattern? Good. The equation for this is y equals x minus 2 squared plus 1. It makes sense. Vertex is 2, 1. Step pattern is 1, 3, 5, right? Opens up because the a is positive, right? Good. Now, this is another equation. Y equals x squared minus 4x plus 5. Does it look anything like this? Does it look anything like the vertex form? The equation. Does the equation look anything like the vertex? Okay. How about your graph?
Same.
It's exactly the same, right? Your vertex is 2, 1.
Yep.
Your y-intercept is 0, 5. Right? Step pattern, go up 1 over 1, up 3 over 1. Exactly the same thing. Now these two equations are the exact equations. Y equals x minus 2 squared plus 1 is exactly the same as y equals x squared minus 4x plus 5. The difference is this is vertex form, this is standard form. Okay? Now, I want you to look at the vertex form. Any of the key feature is in the standard form. Standard form. Let's look at the standard form right here. Okay? Any of the key features, so the y-intercept, the vertex. So look at this.
Yeah.
Okay.
And look at the graph.
Yeah,
The y
same.
is
5 is
5 in the
the
end.
yeah, y
The 5.
And then if you go to the next side,
Okay. So you're telling me that this 5
is the k
is
y
what?
intercept. Y intercept of
Is the y-intercept. That's right. And this is always going to be the case. Okay? In the standard form, when I have y equals ax squared plus bx plus c, this value, whatever that value is, that is your y-intercept. Okay? So, from the vertex form, I can find the vertex easily and I can graph it using the step pattern. Yeah? We learned that last Good. From the standard form, I can only find the y-intercept. And I can't do anything else. I can't use no step pattern, no nothing. Okay? I have to do a table of value to be here.
Okay.
Okay? Now, are you guys okay with this? Are you okay with the big picture? Okay? We haven't converted yet. I'm just showing you that this and this are exactly the same thing. Okay? How to get to it, that's what we're going to do next. Now, key feature of the parabola can you take from each form? So the equation in standard form, can you guys repeat the standard form for me?
Y equal to ax squared plus bx plus c.
Good. It tells the location of the
y-intercept.
y-intercept,
What
which equals to c, which is the last
Okay.
constant. Yeah, it's the constant in your equation. Are we okay with this? Now an equation in the vertex form, which is y equals a bracket x minus h squared plus k, tells the location of the It tells you the location of what? What does the vertex form tells you? X and y.
H and K.
H and K, which are what?
Vertex.
Vertex.
Yeah.
Okay, it tells you the location of the vertex, which is also the vertex is what? If you want to split the vertex apart, what is it? What does it represent?
Vertical and horizontal.
Vertical.
Vertical shift or horizontal? The vertex.
And
Optimal value.
yes, so it gives you the axis of symmetry and the optimal value. Okay, so from the vertex you can find the vertex, which is also the axis of symmetry and the optimal value. Okay? Are you guys okay with this? Now, how can I go from the vertex form to the standard? To go from the vertex form to the standard form, I have to expand. Okay? What does expanding mean? Yeah, the square part, that's right. So forget about that plus 1 for a second, right? You see that this is x minus 2 squared. We just did something like that where we had to write it twice and then forward, right? Now the difference here is that you do the forward, but at the end you're gonna add 1 to it. Okay? So, oops, wrong one. So, it's the same thing as the forward that we just did. I have to write this twice, and then I add the 1 at the end. You don't want to forget that one because it will mess up your whole equation. So let's forward. If I forward this, what do I get?
X squared
Yeah?
minus 2x
Mm-hmm.
minus 2x
Mm-hmm.
plus 4
Mm-hmm.
plus 1.
Good. X squared minus 2x minus 2x and then plus 4. And then you have the plus 1. So what does it simplify to?
X squared
Yeah?
minus 4x
Yes?
plus 5.
That's correct. Do you guys get this? So if I go back to my graphs, This is what I had. In vertex form, it's x minus 2 squared plus, and in standard form, it's x squared minus 4x plus 5, and this is exactly what I got when I went from vertex form to standard form. You see why your graphs are?
They from standard to the vertex form?
Yes.
We can.
So one,
We can go from vertex to standard form. Eric, you must know that. I will be giving you notes about that. If anyone else would like to learn it, I can teach it to you guys. It is not recommended in the MDF 3C. I will not test you on it. I will test Eric. Okay? But if you guys want, I can teach you. I can make one day after a lesson. I can show you how you can go. Okay?
so basically when we use the FOIL in this equation, it gives us the vertex, the standard form.
Yes. So you foil, but you don't forget that you're foiling, and you're also adding that part of the
Okay.
plus one, right? Okay. Now, this is the easiest conversion that you can have from vertex to standard. Now, one step further would be if you have an A value. Okay? So if I have an A value, I have to do a little bit more work to get to my standard form. Okay? Let's see what would that work. No, that's the thing. The -3, you don't multiply it first. Because BEDMAS tells you, you have to do your exponent first. Okay? So that -3, you can't multiply it until after you do your FOIL. Otherwise, your whole answer is going to be wrong. Okay? So, -3, make sure that you do this first. Okay? FOIL, then multiply your -3. And the -3 is only multiplied with the brackets. It's not multiplied with that -4, right? Because that's both sides. So let's do that. If I want to FOIL x plus 1 times x plus 1, what do I get? So,
X squared.
x squared
X squared
X plus X
plus x
plus X
plus x
plus 1.
plus 1.
And then you add -4.
And then you put the -4 in.
And the next one will be multiplied
X
by everything in
plus 2x
That's right.
minus
3x
3.
squared.
So,
minus
next step, you multiply the -3 inside the bracket, right? For every single term inside your bracket.
minus 3x squared.
-3x squared,
Negative 3x.
-3x.
Negative 3x.
Mhm,
Negative 3.
mhm.
Negative 4.
So you see how I multiplied that -3 by the x squared, I get -3x squared. Multiply the -3 times the x, you get -3x. Multiply the -3 times the other x, you get another -3x. Multiply the -3 times the 1, you get a -3. So this is called the distributive property, right? You're distributing that -3 in for everything inside your bracket. Now it's all about collecting like terms, right? 3x squared, -3x squared, there's no like term, so I write them as is. -3x minus 3x,
Minus 6x.
and then -3 minus 4,
Negative 7.
done. Okay? So I expanded from vertex form to standard form, expand, right? Can you guys tell me what is your vertex?
there.
Vertex I can get from the vertex form. What is it?
1, 4.
Is that -1?
-1,
-1,
Negative
-4.
1.
-1, -4. What's your y-intercept?
Negative 4.
Negative 7.
-7,
Negative 7.
right? The y-intercept
Oh yeah,
is
the C. The C is the one at the side.
a -7, right? And then your vertex is -1, -4.
So the whole procedure, we can get the vertex and the y-axis.
Depending on what's given to you, right? So from the vertex form, you can get the vertex, and from the standard form, you can get the y-axis. Okay? So it's converting from vertex to standard. Okay?
Are we recording this? That's it.
Okay, so let's go to the next page, and then after that I will give you time to do the extra questions and to do the homework. Okay? So the questions ask you to state the key features you can determine from the vertex form. Expand the equation to put it in standard form, and state the key feature or features you can determine from standard form. So first, they want you to determine the key features from the vertex. What can you tell me about the key features from the vertex? So what do we call that?
Optimal value is the axis of
The y
symmetry.
axis.
Okay, so let's start with the vertex. What's the vertex?
Vertex
Is the optimal value and axis of symmetry.
I think we just did all of this on the other page.
Yeah.
I think we just answered this whole question on the other page. So we don't need to do that.
Vertex,
No.
axis of symmetry.
So I'm just gonna fill it up here, and you guys can start your next question. Okay? So we just did this whole equation. And I think what happened is when I was photocopying or when I was typing, part of the question went on one page and the other part went on the second page. Okay?